It's my pleasure to introduce Professor Joe Herbert from the University of Cambridge. He, without any doubt, was a huge inspiration during my PhD and was an amazing amount of help because as I was trying to bring different disciplines together, and he was my expert in cortisol, all things related to cortisol. And it's been a pleasure to work with him, and I'm delighted that he's here to talk to us today. Thank you very much, Joe.
Well, thank you for asking me, and you as well. Thank you very much. I'm going to talk about what you'll be talking about and what you'll be talking about, because one of the big problems of stress is what it means. We've heard that repeatedly, and it's used in such a wide and generalized context. I mean, every undergraduate student says, I'm stressed out. What the hell does that mean? Actually, nothing really, but it's become now part of the vernacular. That won't do for us. We've got to pin it down somehow and ask ourselves what it means. Okay, so I'm going to start by showing you what engineers mean, because that's actually where this idea began of stress. Engineers have a very simple and straightforward definition. We're very envious, of course, of engineers. And here it is, here's a bridge, and here are two cars going across it. I defy any of you to tell me what kind of cars those are. I'll tell you later. Very significant, actually. Anyway, there's the stress, and you see engineers talk about the stress, which is the force exerted by those cars across the bridge, and the result is called strain, and the strain, of course, is taken by the cantilevers and so on of the bridge. And so stress is an input, and strain's a response. Now, biologists and medics don't talk about strain. You haven't heard the word strain so far today, have you? You should have done, because in fact, what most people have been talking about is strain, the response to stress. But we don't talk about it. We've got to get a very clear idea in our heads they're different. And of course, as you know, this is a famous picture this is when the strain becomes too great for the resistance or the capacity of the bridge, and that's a train going down there. I forget where this was. I think it was somewhere in Scotland, I'm not sure. Okay, now what is stress? Here we go. This is why I might have the deep trouble by trying to tell you what it is. First of all, it's a process. It's not a single thing. It's an idea. It's a concept, and it begins by being a demand. And a demand means that the person or individual, or indeed the group actually, has some kind of requirement which is outside the ordinary of that group. Now that immediately suggests to you this is not an absolute quantity, but a relative one. Because what is the normal experience or expectation of the individual? It varies. And it can be physical, starvation, that's a stress. Now what is starvation? Well, if you're a Danish middle class person, the word is unknown to you. But if you live in New Guinea, the word is not unknown to you. And many of these people actually will have suboptimal calorie intakes, and that is a stress, because your body responds to that in a certain sort of way. The same goes dehydration, also in New Guinea, I guess, and not common in the UK really, because we don't get much heat. But when we do, the whole country becomes dehydrated suddenly, and temperature and so on. Now, so those are stresses. And your body has a well-recognized way of dealing with that, tiding you over until such time as you can counteract that stress. And of course, part of the stress response is the means for doing that. The fact that you look for food, or you're hungry or thirsty, is a response to a stress. That's as much of a stress as anything else. Second class of all are personal. These things here, okay, work demand, relationships, and so on, and a loss. I'll talk a lot about loss, because loss actually is a common element of personal stress across all cultures. Because what the loss is will be culturally dependent and social. Now, the last important thing, and this makes the water even muddier, of course, is that these things interact. If you have a community which has not much food, you're going to increase competition, aggression, and so on in that group. You're going to accentuate or depend upon interaction with other people to give you the food you need, and so on. So these categories that I've put up here actually are interactive. So stress is a very complex physical, psychological, social phenomenon, as if we didn't know that, but it's true. Now, these are the objective things that you and I, going out in the field, would measure. Duke, in her New Guinea population, is looking at the people and saying, I wonder if you're stressed. In fact, stress is not is an objective statement, but it is a subjective response. And the two are not the same. That's the important thing here. And the responses, which are strain, which can be strain, and here is the important thing here is that it's seen as, first of all, significant, it matters. Secondly, it's seen as an adversity, something you'd rather you didn't happen. And thirdly, it's seen as something which might or may not be dangerous to you. In other words, it's devaluing your life in some way. And any of these things can do that. Now, the response, which engineers call strain, is again across three dimensions, and they're not, again, independent. They relate upon each other. First, upon the physiological, you've heard lots about that so far, the autonomic one, which Dan Woods talked about, the hormones, which Duke has talked about, and also and here, and the immune response. We haven't talked about immunity much yet. I won't talk about immunity because it's a too complicated situation, but it is part of the foster stress. Okay, and the emotional one, of course, this is when we come into the idea of the unpleasantness of the experience of stress, which people don't actually enjoy. That's a very important actually function of the brain. The brain is a very clever organ, would you believe, and it makes you not like stress. And that means you do something about it. If you didn't mind about it, you wouldn't do anything about it. Same was hunger and thirst and everything else. Okay, the fact you find these states unpleasant or not worth enduring is part of a very clever mechanism of your body to counteract the situation in some way, if it can. And here, of course, cognitive. The evaluation of the situation is the assessment and the strategy. What are you going to do about it? All these things are cognitive. And what happens? Well, these are the things of what can happen. The idea of coping was introduced by Lazarus and Faulkner many years ago now, and this is the idea that you actually adapt to the stress, or you don't. And it's not always, of course, a sharp dividing line. And second, but adaptation is really the function of this. But remember, and I think several people have mentioned this already, that even if you adapt, there's often a cost. The benefit, you may get over the situation, or you may apparently get over the situation, but in there is a cost. And we'll see some of that costs in just a moment. Okay. In real life, there are things called life events, and they're particularly important in one of the sequelae of stress, which I'm going to talk about, which is depression. Now, depression is not the only result of stress, as you've already heard. I think it was you who showed a huge great list of things that could be related to stress, and I'll show you a few more. But depression is a common one, and it's a serious one, and it's one which has terrible consequences, one of which is you become less able to deal with stress. And one of the things that is striking is that if you look at the history of people with depression, a large proportion of them, and it's possibly 100%, although we don't know that, have an identifiable life event. Now, a life event is this. There are good life events, allegedly, here, okay, and there are bad life events, and we're talking about the bad ones. And here are some of them, or others, and any of these things can precede a bout of illness. And they, of course, are stressors, because they represent an adversity, a discontinuation, an unpleasant event, something which you'd rather not have happened or needs to be restored in the lifestyle of that person. The point about here is, again, the two things. First of all, these are objective statements, but they aren't all undesirable. I mean, to put it cruelly, death of a partner or a parent may not actually always be undesirable. You have to face that fact. All right, in most cases it may be, but you can't assume it. and so on and so forth. Okay, so there's an objective definition, but a subjective and individual evaluation. And it's particularly shown here because although a large proportion of illnesses, in this case depression, are preceded by a life event, most life events are not followed by depression. And that means there are individual differences in the way which people respond to stress. And the question is, what do we know about it? What do we know about it? What separates the sheep from the goats? And so on. Well, let's see. Here's a good example. This is work done ages ago, actually in Cambridge, as a matter of fact, by Surtees and Wainwright, and they looked at a lot of women, 207, whose husbands either died or had a heart attack. In other words, were in danger of dying, or so they thought. And they looked at them and they followed them up after several weeks, and they showed after about 20 weeks or so, there was a big peak in either depression, that's MDD, major depressive disorder, or anxiety. And about a third of them showed that peak. Now there are two things about this which are interesting, or three things really. First of all, they happen at all. That's interesting. I mean, it shows that a life event can result in a pathological, a clinically recognizable situation. Secondly, there is this gap. So what's happening here? I should tell you that not everybody gets this gap this long. Other people say it's about 12 weeks. But anyway, there is a gap. So what's happening in that gap? Something going on. And thirdly, as I've already said, not all of them show it. So why don't some and why don't the others? This is an example, therefore, of a relationship between something horrible happening and a neurological, or in this case, neuropsychiatric response. Okay. Before I talk more about it, just let's spend a moment considering what happens to people with depression, because it is a very serious illness. And because it's common, and because it's often not talked about, doesn't mean to say it's not serious. The commonest age for the onset of depression is adolescence, and that's often not understood. The instance or prevalence of depression in adolescence, and we've studied this, me and my friend Ian Goodyear, is about 1 to 2%. That's quite high. That means any big school, there'll be at least half a dozen people or so who are pupils who are at that point clinically depressed, of which more than half will not be recognised. That's the first thing. Well, what happens? Well, it has dramatic effects. It wrecks education, which can be permanent the rest of their life. They have no friends. People with depression aren't fun to be with, as I'm sure you know. They can't be friends. It can recurrence, often does recur during adulthood. Many instances of adult depression, in fact, have started unknown in adolescence. Okay, there are problems with the family and of course suicide. Adolescent suicide is a real danger. In adults, a similar picture, but other things, of course, recurrent again. Low self-esteem, which is a common phenomenon in depression, can damage a person's self-image really for their entire life. You can lead to drug abuse, which is often self-therapy. It causes dramatic effects on employment relationships and so on. Here are some of the long-term effects. We've heard some of these already before, but here are two that I want to mention. One is heart attacks. It's now demonstrated that people with chronic depression have a high incidence of heart attacks, and no one quite knows why. And even more worryingly than that, the risk for Alzheimer's is about double. And there's, I can talk to you about that more, but I won't about that. And of course, the economic results, both personal and the community. The UK, it reckons the UK costs about 60 or 70 billion pounds a year depression. That's a considerable sum, but in any country, particularly one about to leave the European Union. Yeah. Right. So let's start now. How do we know who does what? How do we know who gets depressed in this case? I'm using depression as an example of an individual response to stress, but remember there are other responses too, and they're also individual. But let's talk this one. First of all, genes. And these are human chromosomes, as I'm sure you know. Okay, now, this is where we get our first look at the brain. Now, some of you, this is very familiar, and I apologise, others who may not know this. This is serotonin in the brain. Now, serotonin has a long and checkered history in the context of stress and depression, and I'll say a bit more about this in a moment. If you ask most psychiatrists what is the cause of depression, they say low serotonin. They are absolutely wrong about that, but they will say it. It is the reason they say it is they have no other answer to give you. I say they. I'm not a psychiatrist, thank God, but I'm actually a medic. But I sympathise with them, and it's our fault, our being the neuroscientists. We haven't given the psychiatrists the information they need to be able to diagnose their illnesses at a neural level. But they will tell you that is. However, serotonin has an extremely interesting role in stress and resistance to it. And the important thing about serotonin is its anatomical distribution. It all comes from nerve cells which lie here in the brain stem. There are no nerve cells in the entire brain containing serotonin, apart from here. That might surprise you. All the serotonin, and there's lots of it in the brain, it looks as if here it's all over the brain. It's not really. There are actually patches of it in different parts. But all of it comes here from the brain stem. So if you destroy or alter the function of these groups of neurons called nuclei, or raphe nuclei they're called, you alter the entire brain. That's very important to understand that. Okay, now, how does it go with genes? Well now, I must tell you that when serotonin is released into the brain here, it does two things. It acts upon the next nerve cell through receptors. Now, receptors are absolutely essential for any kind of chemical response, either hormonal or neurochemical or immune. The receptor, that is the thing which detects the presence of this molecule, is as important as the molecule. Much harder to measure, so that's why it often isn't talked about, but it is. Now, the other thing that serotonin does, the brain of serotonin is, it limits its action. It sucks it back into the terminal, which is release of serotonin, like a kind of vacuum cleaner effect, like that. So it's limited. Now that's called a serotonin transporter. And why is it interesting? It's interesting because nearly all the drugs that treat depression, SSRIs, act on that molecule. SSRI stands for specific serotonin reuptake inhibitor. And reuptake is this molecule. So, let's look at the molecule. Here it is. Here's the gene, actually, which produces the molecule. I won't show you the molecule because it's a large, complicated protein, which is not very interesting, really. What's interesting, however, is this gene. Now, this gene, like all genes, has a promoter. These yellow things are the bits of the gene which actually produce the amino acids. They're called the exons. And in between are things that used to be called junk DNA, and now are not called junk DNA because they're far from being junk. However, what we're interested in here is promoter. The promoter is the thing that turns that gene on. And in that promoter, there is a thing called a CNV, which is a sequence of base pairs which are repeated. Now, as you may remember, DNA has 4 base pairs. You can imagine 4 coloured beads on a necklace. And this particular necklace has 44 beads in a particular order. And another 44, and another 44, and another 44. In fact, there are 14 44s in some people, and 16 in others. Okay? There. So the 44 beads on the chain, repeated either 14 or 16 times. Now, all of you in this room have either got 2 short ones, 2 long ones, or 1 of each. Do you know? No, you don't. Do you care? You don't now, but you might in a moment. I'll tell you why. This is a famous paper, published quite a while ago now. It is the most cited paper in behavioural genetics for a very good reason. It shows a wonderful interaction between the genes and the environment. The thing that everyone's been talking about for years was never actually been shown very clearly. And what do they show? Well, they followed something over 1,000 New Zealand young people. And they asked them some simple questions. They said 2 things. First of all, how many life events, things you've already seen, have you experienced? 0 to 4 plus. And secondly, have you or are you depressed? They actually use depressive symptoms rather than full depression. I was like a bit miserable. And they found a fascinating finding. If you had 2 copies, or they had 2 copies of the long, okay, there wasn't much effect. Look, little increase if they had lots and lots of life events. If, however, they had 2 S's, huge effect. So nothing here. And as the number of life events increased, so do the chances of them having depressive symptoms. And very satisfactorily, if you have one of each, you're heterozygous, to use a official term, you're in between. In other words, there was a genetic determinant in the way in which these people responded. Wonderful example of nature and nurture. I think I'll come back to it in a moment. All right. So that's one example, but it's not the only example. There are lots of other genes that have an effect on the way you respond to stress. This is an example of how it can happen, of how you can demonstrate this interaction. Right, hormones. Now we've heard lots about hormones so far. Here's a bit more about hormones. Are they individual response to stress? Well, let's start with adrenaline, you've heard about. You can hear the adrenal glands, which have a star role in any story of distress. Not the only ones, there are other hormones too. This is the one that everyone talks about, so I'll talk about it too. Okay, they produce, of course, 3 lots of hormones: adrenaline or noradrenaline, cortisol, and DHA. I won't mention DHA, though it's fascinating as you get older. But I will talk about this. Let's talk first about noradrenaline. You've heard about this already, so I'll go over it quite quickly. You'll see it's an acute response like that. Now, adrenaline is the kind of thing that happens if you're crossing the street and a car goes around the corner and just misses you. You jump back, okay? Your heart goes pitter-pat, you perspire, you breathe quick, you go, you feel anxious and so on. That's adrenaline, okay? Or noradrenaline. They come out and there's been a lot of discussion about whether adrenaline and noradrenaline are different things, but no one's decided that. It's very short-acting. Now, think about noradrenaline and adrenaline. There really hasn't been any convincing evidence that unless it happens regularly, you don't have a car, out of the way of cars all the time, that there hasn't any long-term effect on our health. They do have a short-term effect, and here's a short-term effect. There are lots of interesting things. There is noradrenaline, which is actually no adrenaline. Adrenaline, very simple molecules you can see, benzene ring, a little side chain. They do all these things here. I won't go over this because you all know about this. But the thing I want to talk about particularly here is the brain, because I'm a neuroscientist, you see, I have to talk about brain, and at the same time, of course, as well as doing all these metabolic things, which are very important, blood to your muscles and so on, and keep your blood with glucose so you have more energy, all those things, and they reduce the fact you're digesting your breakfast, because the last thing you want to do is worry about digestion when you're avoiding a speeding car. Here's the interesting thing, because here's something interesting. How do they do it? Because adrenaline and noradrenaline don't get into the brain. So why is it that when you're jumped out of the way of this car, you feel fear or arousal? You're awake, you're not asleep, are you? You're looking around a bit and saying, "Oh, I was near one." Well, I'll show you. Within the brain, there's a separate system of noradrenaline. Very interesting. It comes, as you can see, rather similar to serotonin. Different nerve cells, but the same position down the brain stem. And again, all the noradrenaline in the brain comes from actually more than one. It just shows one here, but there are several nuclei in the brain stem which produce noradrenaline. Interestingly, noradrenaline is released into the brain under the same sort of circumstances as your adrenal gland releases adrenaline. In other words, here the body and the brain are working together to produce this acute response to get you out of danger, fight or flight. All right. However, more interesting from our point of view is cortisol, about which we've already heard. I'm fascinated with the idea of measuring cortisol here. I've never done it, but it's becoming now very fashionable. And the interesting about that is, as Duca has mentioned, is gives you a long-term view of what cortisol is. The same way as, for example, measuring glycosylated hemoglobin in diabetics gives you a long-term view of their blood sugar, which in some ways is more informative actually than daily ups and downs. Anyway, here's cortisol, and it goes on for a long time. And as you see, as you heard, unlike noradrenaline, which peters out in minutes very often, or at least an hour, cortisol doesn't. It goes on and on and on. It can go on and on if the stress is persistent. So, does it matter? Now, cortisol has some dramatic effects on the body. Okay, again, first of all, it's elevating the stress for particularly stress, which is just perceived, and here we get back to the individual perception of stress, as perceived as being uncontrollable, unpredictable. Uncontrollable can be several things. First of all, you don't know what to do, or secondly, you have no resources upon which to draw. For example, if suddenly you have a huge bill, a huge demand on your finance, okay, do you have somewhere to go to borrow the money? Or can you negotiate with the company, or whatever? Okay, if you can't do any of these things, then that's a much worse stress, obviously, than if you can. The second interesting thing about, so the elevation of stress depends, as I repeatedly have said, on individual characteristics, not just the reflex relationship between a stress and a response. The second thing about cortisol, and this gets right to where we're talking about, is that it increases the risk of brain damage. Now, this is interesting. There are many things that damage the brain, toxic substances, for example, and some of them don't damage the brain very much. But if cortisol is high, they damage the brain a lot more. It's a bit like walking along the edge of a cliff, like that. You're looking out at the sea, and suddenly, unknown to you, a huge blast of wind comes here and blows you towards the sea. Now, depends how close you are to the cliff. If you're close to it, you may go over. If you're 50 feet away, you may not. Cortisol moves you towards the edge of the cliff. So by itself, it may, you'll see a moment, do brain damage, but interestingly, it increases the other things. And it may do the same thing, not just with physical damage, like toxins and neurotoxins, but also with psychological impact too, as we'll see in a moment. So it potentiates, it pushes the brain towards the danger zone. I'll show you more about this. Interestingly here, that giving those with higher than normal levels, those with higher cortisol levels are at high risk of depression. If you take a whole collection of adolescents and you measure their cortisol, and many other things too, and then you say, who gets depressed over the next 4 years? The level of cortisol is one predictor. Only one predictor. So you walk around with cortisol levels which may or may not be a risk for depression, just as it is a risk for brain damage. Of course, depression is a form of brain damage. Even though, okay. I'll show you this in a moment. Come back to this, but you can prove this by showing what happens to people who get given cortisol. And there we are. Interestingly, and this is a confusion, there is both a ratio of cortisol to risk of depression and cortisol in depression itself. I won't talk about the second, but just to show you a picture here, this is a characteristic diurnal pattern, which Duke's already shown you, of cortisol, high in the morning and low in the evening. This is the classic shape in depression, where it's a little bit raised in the morning. What happens is the decrease during the day doesn't happen. That's an extremely important physiological change. The brain and the body need a period of low cortisol. They don't get it, that's a problem. I can't talk about it anymore, but just to let you know that there is also part of the pathology of depression in some people, because depression is not a single illness, depression is a multiple illness. In some people, there is an abnormal pattern of cortisol. However, here is a lady with Cushing syndrome. One of the myths of medicine is that if you obscure someone's eyes, you can't recognize them anymore. You saw that, didn't you, in the previous? It's completely untrue, isn't it? We all do it. It's kind of, it's a legitimate way of showing pictures of people without asking their permission. You know? In this stage of Cushing disease, it's Cushing disease, and she has this classic moon face, and here is her tumour in her adrenal, which is producing lots and lots and lots of cortisol. And she has increased body weight, a moon face, hypertension, memory. But here's the important thing. a large proportion of these people are depressed. And as soon as you cure the Cushing's disease by taking out the tumour, whatever it is, depression lifts. So giving cortisol does cause depression. Sadly for them, the cognitive memory impairment, and I'll talk to you more about that in just a moment, may not recover so well because there may be permanent damage to another part of the brain called the hippocampus. Okay, here's an amazing bit of a study done actually in the UK. One of the good things about National Health Service is you have a huge database because everybody's registered. So people like Fardeck and Co. can go to these databases and do large-scale studies. This is a magnificent study with 1.5 million subjects. Now that puts most of them in the shade, okay? Not many of us have done an experiment with 1.5 million subjects, but they did, and they demonstrated, you can see, that those patients who in any kind of their life had any kind of glucocorticoid therapy, which is very common, asthma for example, or arthritis, or some called bowel disease, or immune suppression of course is the other one. Many people have corticoids. You can see that there's a great increased incidence of a whole variety of psychiatric illnesses, apart from being referred to psychiatrists, which, turns out is another story. But the point about here is, of course, that there may not be a one-to-one relationship between stress and mental illness. There's no reason why there should be. For two reasons. Mental illness may depend upon the reaction of the person, and second, the definition of mental illness is absolutely hopeless. All right, I'll tell you why later. Okay, now, another source of stress which is being increasingly recognised as extremely important is early adversity. For some reason, and we don't quite know why this is, the very young brain is extremely sensitive to adversity. Adversity usually means poor parenting in this Western culture. Other cultures it can mean, of course, starvation or dehydration or high and low temperature, physical stresses. But in the Western world, it usually means various forms of poor parenthood. All right. Childhood adversity comes in various ways. There is, of course, physical, which means parents who beat up their children. It can be sexual. We all know about that. It's a hot topic in the UK, and I guess probably here as well. Psychological, all these things too, which can impact upon the child. There are the wider influences of here and so on. And here is what happens. If you look at childhood adversity, and let's for the moment ignore everything else. You can see that there's an increase from mental disorders. I've already shown you that. There's delinquency and a low rate of educational achievement. And of course, the other thing about early university is that it predisposes people often to life events because their lives are basically more problematical than they will otherwise be. So you get a compound effect of early adversity and later adversity as well. The problems with studying childhood adversity, and there are very considerable problems here, is how you study it. The first problem is you study it retrospectively, usually because the children have grown up, and you ask them what happened. Do they remember? Will they tell you? Okay. Secondly, who do you ask? If you ask the parents, they're actually people who do it, so they're not going to give you an honest answer. Onlookers, well, who do you ask? Teachers, will they know? Relatives, will they know? Neighbours, will they know? And so on and so forth. And the actual measurement thing too is a problem too. How do you actually measure? Put a number on some of these things. These are all problems about which we're all familiar with about psychological or sociological measures. They are a problem, but nevertheless, the general story seems to be there. And what happens, interestingly enough, in animals and possibly in people too, is that early adversity has a permanent effect not only upon the brain, but also upon the endocrine system, and in particular upon this cortisol system. Because something happens early in life, okay, which has a whole series of effects, and you can read them down here. Particularly that one is interesting, okay. In other words, you change the way a person responds to stress in later life by exposing him or her to adversity in early life. Now, why is this? What's the mechanism? If you'd asked me that 10 years ago, I would have no idea. But now I do have an idea. It may be wrong, but the idea is this. I'll talk to you very briefly about epigenetics. They have become an extremely interesting, but still early, area of research in stress and adversity. The reason is this. What is epigenetics? Well, this is DNA, okay, this string thing, DNA, and inside here, these sort of greeny things are histones. And histones are proteins around which DNA is wrapped. Now, these sites here are the sites where you can put it on a methyl group. And they're not random, there are particular areas of DNA. If you do that, then you change the way in which the DNA is wrapped around these histones. Doing that changes the way in which the genes are expressed. So if a particular gene or a particular area of DNA becomes methylated, then that gene may be more, maybe less expressed. If you acetylate it, which is another way of doing it, you increase the expression. The important thing here is, this is very interesting indeed, that the methylation of these genes can be influenced by early experience. It's been shown most dramatically by Mike Meany in Canada in rats. What he did was, he took lots of mother rats, and he watched them. And some of them were very good mums. They licked their babies. If you put the babies out into the cage, they rush out and bring them back and so on. Others were less, they were laid back. As soon as you were watching television and things. And they didn't groom them very much, and they didn't bother pick them up and so on. And he demonstrated that the two things. First of all, these baby rats that had rather poor parenting, when they grew up, had a much bigger stress response than to a common stressor than the others, the more secure ones. And secondly, the mechanism, this is the important thing, was changing methylation. Somehow, and we don't know how, somehow this early experience had acted on the brain to change the methylation pattern of a particular gene, in this case, which was concerned with glucocorticoids. There have been a number of studies of other genes as well, and indeed some suggestive studies on humans. In humans, of course, you can't study methylation in the brain, but you can study methylation of related molecules in the blood, and there has been at least 1 or 2 studies showing that this is true for children as well. So, this is an extremely interesting thing for 2 reasons. It shows how a mechanism for how early experience or early adversity can have a long-term effect upon later behavior, lifelong, because methylation lasts for a very long time, possibly forever. And secondly, of course, this is really interesting for me, it blurs the distinction between this nature-nurture, this boring argument which has been going on for about centuries. Even Darwin had a go at it, and it didn't. And about is it a gene, is it an environment? Well, madam, it's both actually, as a matter of fact. And this is a mechanism for showing that in fact the two may at some point be the same, which we all knew, didn't we? Except we couldn't actually prove it. Now we can. That's why I like genetics. It stops geneticists being so proud of themselves, and it stops social psychologists knowing it all. Right. Here's a hot topic: gender. I haven't mentioned gender so far, but there are gender differences, and they're pretty important. Okay. First of all, unlike you, actually, we did find sex differences in these were in adolescents, so it may not be the same as your elder tribesmen. We find that if you do salivary cortisol in women, or to girls actually, they're about 20% higher than males. Does it matter? Wait. Right. Now, in general, if you give a psychological stress of all sorts, males tend to respond more than females, which is interesting. But this depends very much, actually, upon the type of challenge. For example, if you give something which involves achievement, males like showing off, like to be the boss. Males have a much bigger response than females. For example, if you say, right, stand in front of the class and take 7 away from 99 and go on taking it. Cassie tests right. Males do it, females do it as well, but males have a huge great cortisol response and the females a small one because they feel that they're going to show themselves off against their classmates. Classic example. However, it isn't all males, because social rejection, for example, which can be measured in various ways, and interestingly, the illness of the child. If a child goes to hospital, the mother shows a much bigger cortisol response than the father. You can argue about why that is, but it's true. Okay. Interestingly, too, females report more life events than males. No one's quite decided whether a reporting thing or a real thing or what it is, but it's a consistent literature females report. So here you have a whole collection of things, both the response to stress and the advent of stress, which tends to push females in a bigger direction than males. Does this matter? This is the incidence of depression in males and females. The horrifying figure is that 1 in 4 females at some point in their life will have a bout of clinical depression. 1 in 4, 25%. That's huge. Of those, as I've said to you, even in a sophisticated country like Denmark, less sophisticated country like the UK, a small proportion of those actually be diagnosed. And even a smaller proportion will get to a doctor. Okay? In men, it's much less, about 1 in 8 or 1 in 10. Okay? Now we don't know the difference, the reason for that difference. We don't know whether it's reporting or whether, but if you do a kind of community survey, it stands up. So it isn't just people coming forward the whole time, it seems to be real. Let me remind you that depression is not a single illness. It is a symptom of a variety of illnesses, so we don't know whether that may factor into this as well. What time do I have? Am I running out of time?
5 minutes, so we have a bit more time, for questions.
Oh God, I'm running out. Okay, I'll miss this then. Right. Brain. It took me a long time to get here, but I got here eventually. Here's the brain. What do we know about the brain? Okay. The first thing we know about the brain is this structure, the hippocampus. Hippocampus lies here like that, and it's part of the brain which you know is concerned with particular memories, particular recent memories, and they're transferred to a more permanent store, but also things like episodic memory, that is, if you remember how you got here this morning, or whatever, but you have no idea what you did this time last week, okay, that's episodic memory. Or if you ask you what happened on your last birthday, you'll remember that, episodic memory. Okay, that's the, and also spatial memory too, which is really part of episodic memory, finding your way around. There's a famous study on London taxi drivers that maybe something you may know about. They have bigger hippocampi than the rest of us, because they have to learn what's called the knowledge, which actually is now being superseded by sat-nav. But in the days there was no sat-nav, they could recite every street in London. It took them 2 years to do this. Anyway, they had big hippocampi. The ones that failed had smaller ones. Very exciting. Anyway, for what we're interested in is cortisol. What does cortisol do to the hippocampus? Well, the hippocampus is extraordinarily sensitive to cortisol. It's full of receptors, I mentioned earlier on, to cortisol, and it does at least 2 things. These are some individual nerve cells, and you can see they're surrounded by these branches which are called dendrites. Dendrites, there's one, somewhere in here, there's one single axon, which is a connection to the next nerve cell. But all the rest of those things are dendrites. What he's doing is holding out his arm like aerials, listening to other neurons. And all the other neurons are connecting to it by connecting to these dendrites. Now what cortisol does is it reduces that branching. If you look at neurons with animals which have given high doses of cortisol, they're retracted and they're fewer and they're deformed. Dendrites can change their shape quite dramatically in the normal brain. It's one of the ways in which the brain is plastic. So that's one thing it does to it. The other thing it does to it is this. Now, the hippocampus is a very extraordinary bit of the brain because unlike any other bit of the brain apart from one, okay, it goes on making new nerve cells throughout adult life. And that includes you, ladies and gentlemen, okay, and a rat. And this is part of the hippocampus here, and these little green things here are a special stain which picks out new neurons, newly formed neurons. They come from progenitor cells. They're not really stem cells because stem cells can do anything, and these things are kind of programmed to make neurons, so they're called progenitor cells. But they're stem-like cells, and they sit there in a quiescent way along the inner layer here like that, and then they, at some point, they suddenly develop into mature neurons and move out here into the edge and produce all these lovely dendrites. Okay. Now, cortisol turns this off dramatically. I tell you, we've done this in rats, and you can get down to about a third of the level of cortisol. So if you have a high level of cortisol, you've stopped making new neurons. Does this matter? Actually, no one quite knows about that, but it probably does. Okay, fine. Right, what about other parts of the brain? They're important too. Here's the amygdala that you haven't heard about yet, but it sits up down here and it's highly concerned with emotionality, particularly fear. And it's full of corticoid receptors, and corticoids increase anxiety, and they increase propensity for anxiety down here. Here's the hypothalamus, next door, which is responsible for generating the pulse of cortisol in the first place. Hypothalamus sends a message down to maturity, maturity down to the adrenal, and then the adrenal back into the amygdala here. And here's the cortex, which of course is concerned with these high-level cognitive things like assessment and realization of a particular circumstance and the recruitment of resources and so on and so on. So stress looks like this. Cortex, what is it? Cortex, what is that? This chap's pointing a small piece of metal at me. Goodness me, it's a gun. Okay, you know that because you learnt about guns. You're not born knowing about guns. Cortex. Is it a threat? Yes, amygdala. Okay? I'm in danger. What do I do about it? Well, first of all, okay, I remember that it's a gun. I know what it does to it, okay? The cortex, I get a strategy. I duck and run away. Okay? Hypothalamus, I increase hormones. Hormones feed back in the brain to affect how I perceive things, interestingly enough, and my emotional response to them. So here you see, don't you, the neural network, which has all to do with stress responses, both complex things and more primitive things, and very primitive things here, which regulate your survival. I finished, except just to remind you that mental illness is a common and serious problem. These graphs here show the incidence of illnesses at various points of lifestyle. This is 6 days old, this is 80 years old down here, okay? So increased age here, males and females. And you can see here that, for example, cancer, as you know, gets more common as you get older, and so does cardiovascular disease. But here is mental illness. And you see, can't you, mental illness is very much a disorder of young people, although of course it can persist into later life. So, if we want to understand how to predict and prevent mental illness, we need to know about stress. I'll just finish now by showing you, I think someone showed Hans Selye before, someone did. He was a father of stress research. He was an Austrian-Hungarian who worked most of his life in Canada, actually, and is responsible for a lot of what we know and think about cortisol and stress. He demonstrated, first of all, that stress is not bad for you. He said this is cortisol. If it goes on too long, it gets bad. Absolutely true. A short burst of cortisol may be good for you, but too much and too long is bad for you, which you've already said is absolutely true. That was, and he said this amongst many other things, absolutely true. And now I've finished. Thank you.
Thank you very much.
Just a tiny addition on Hans Selye. I read that his English was very bad, and actually he meant strain all along, but he thought stress, and he was blaming himself for the rest of his life that he didn't call it strain.
That's right. I remember that. I've forgotten that. Quite right. He did. Yes, he did. And nobody else does too. It's very bad. We should talk about strain because that's the response. The stressor is the objective occurrence. The strain is your subjective response to it, which is quite different, of course. The link between them is highly variable. So if you talk about stress, you don't know whether you're talking about, an examination or whether you think you're going to pass it or not. And they're quite different, obviously.
quick follow-up question on that. Why adolescence? Why are we so vulnerable? I mean, we know that the prefrontal cortex is basically, well, not shut down, but this is why teenagers are incapable of making sensible decisions. I mean, there's lots of stuff going on there. That because it seems like such a high-profile time for a system to be sensitive, and from an evolutionary perspective, have you got any feelings as to why that might be?
One word: puberty.
Yeah.
Puberty is such a dramatic change in the body function and the brain function of both individuals, of both males and females. This is what happened. It used to be said that mental illness didn't occur before puberty. That's not true, actually. But there's a huge surge after puberty, and it is puberty. I haven't got time to talk about this because it's another subject, but the steroid hormones, particularly testosterone, but also estrogen, has a huge effect on what the brain does and how it views life and how it changes interactions, and indeed interacts with cortisol actually too. There's a very interesting lot of papers now, interaction between testosterone and cortisol. So the brief answer to your question is puberty. Okay. It's exciting but dangerous.
Perfect. Thank you very much, Joe. Okay, one more question. Victor, I'm going to...
No, I think that was an excellent talk. Thank you so much. I just wanted to add in your last slide where you show mental illness that it actually doesn't get better in the later life. And what happens is what happens is that individuals with mental illness tend to die 25 years earlier on average. Than the rest of the population.
Yeah,
so
they do.
That's why you see a decrease. I also like very much that you bring up the point about the vulnerability of children during development, because one often doesn't hear that in the circles. What you hear is that children are resilient, and there's really nothing in the literature that supports the idea that a child is resilient just by virtue of being a child. In fact, the literature points to the opposite.
Of course, some children are resilient. Again, it depends very much on the child, and it depends very much, particularly on the genetic of the child. Genes will play an increasingly heavy role early in life, obviously, because the nature has a big role. Nurture hasn't happened very much. In fact, nurture is a problem here very often. So it's going to be largely the resilience of the child. And of course, not all children who come from terrible homes turn out terribly. We all know that, but many of them do. And there has to be a reason for that.